Hey guys, what's up? My name is Chris. Welcome to Adapt Tuition, and in this video, I'm going to show you how to use matrices to solve simultaneous equations. Okay, so before we go any further, I just want to say, if you are brand new to matrices and you have no idea what's going on here at all, before you watch this video, I want to strongly suggest that you check out my previous videos on this topic. I'm going to put links in the description below, so please go there and check out those videos, and when you understand them, especially how to multiply matrices together and how to find the inverse of a 2 by 2 matrix, you can come back here and you will get the maximum benefit that you can out of this video. If you are already comfortable multiplying matrices together and finding the inverse of a 2 by 2 matrix, then let's get started. Okay guys, so let's just jump right in. So we have a pair of equations here, which is 2x plus 3y is equal to 5 and 4x plus 5y is equal to 7. The first thing to do when we are using matrices to solve simultaneous equations is to convert from equations to matrix form. It's actually a very simple process, and all we're going to be doing is taking the coefficients of algebraic terms and making a 2 by 2 matrix with those elements. So that's going to look like this: 2, 3, 4, 5. Also, what we're going to do, we're going to take the algebra, the x and y, and create a 2 by 1 matrix. And on the right hand side, after the equal sign, we are going to simply put the elements, sorry, not the elements, the other two items, the 5 and the 7, in another 2 by 1 matrix here. So step 1 is convert from matrix form to equation form. The second step that we're going to take is to label the matrices. Now, in some questions, you are already going to get names for the matrices, but if you are not given names, what I strongly suggest is you give them names, and simple names. You can name them A, X, and B, right? So generally speaking, the 2 by 2 matrix is usually the matrix I label A. The algebraic matrix, or the matrix, the 2 by 1 matrix with the algebraic terms, that's the matrix I label X, and the matrix on the right hand side of the equal sign, that's the one that I label B. So the reason that I label the matrices is because that facilitates statement making. The statements that I'm going to show here, you don't have to write all of them. There's one specifically you need to write, and I'm going to show you which one that is. But your statements show the person who is correcting your paper that you know how to solve for the unknowns. So it's actually a very simple process. We remember the inverse of a 2 by 2 matrix? Well, what we're going to do is we are going to multiply the inverse of A on both sides of the equation. Now you might be asking why? Well, remember from my previous video, when you multiply the inverse of a 2 by 2 matrix by the original matrix from which it was derived, we get back I, the identity matrix. And we said that I, the identity matrix, which in this case will be 1, 0, 0, 1, as you will see, what happens is that when you multiply I by any compatible matrix, well, multiplying by I is like multiplying by 1. All that's going to happen is we're going to get back matrix X. So what we've essentially done is we've moved A from this side of the equation to the other side, thereby making the matrix X the subject of the formula or the equation, and all we have to do to solve for the elements in X is to solve the right hand side of the equation. Okay, so before I go on to finish the process of solving this equation, I just want to pop in here very quickly to address something that some of my students ask me sometimes. And the question is, well, we have this line here, which is A multiplied by X is equal to B. And let's just come out of matrix mode for a little while. Let's just imagine that this was simply an algebraic equation and we had to solve for X. Now, normally if we have to solve for X, we have to remove anything currently attached to the X. And we remove it by doing the opposite of the operation that attaches it. What's the understood operation here between A and X? Well, multiply. So how do we remove something attached by a multiplication? Well, we have to do the opposite. We have to divide by it. And whatever happens on one side of an equation must also happen on the other side of the equation. So on the left-hand side, we'll see A cancelling with A, leaving us therefore with X being equal to B, essentially divided by A. But the problem here is that when we do have to come back to matrix mode, I guess you could say, is we have no division operation with matrices, at least none that I know of for this level, the CSEC level. So how do we fix that? How do we work around that? Well, actually, it's not that bad. It's not that hard to see why multiplying the inverse works. Consider, once again, b over a. This is b divided by a. But what I'm going to do is I'm going to split this apart as b over 1 by 1 over a. Because remember, when you're multiplying fractions, you multiply numerators together and you multiply denominators together. And we also know, since multiplication is commutative, it doesn't matter the order in which you put these items. So b over 1 by 1 over a is the same as 1 over a by b. And from laws of indices, we know that 1 over a can be rewritten as a to the power minus 1. And what we are seeing here is essentially, therefore, that multiplying the inverse of a by b is the same as taking b and dividing by a. So that's why doing this, multiplying to solve this for x, that's why multiplying by the inverse on both sides of the equation works. Okay, so it seems that all we really have to do is find the matrix A inverse and multiply it by B. So let's do that. Let's find A inverse. So if you recall from my previous video, the inverse of a 2 by 2 matrix in this case is 1 over the determinant of the matrix multiplied by the adjoint of that matrix. If we recall, the determinant is simply the product of the elements on the lead diagonal minus the product of the elements on the secondary diagonal. And the adjoint is where we swap the position of the elements on the lead diagonal, and the elements on the secondary diagonal are each multiplied by minus 1 or divided by minus 1. Essentially, they take the opposite sign to what they originally had. Okay, so just very quickly, 2 by 5 will give us 10, 3 by 4 is 12, 10 minus 12 is minus 2. So our A inverse is essentially negative a half multiplied by 5 minus 3 minus 4, 2. And like I said in that video, I suggest you leave the inverse in this form instead of trying to multiply the 1 over the determinant by all the elements inside, which will just give you fractions. It's cleaner and easier to work with. And once again, just like in that video, I will say, I'm not saying don't work with fractions. I think everybody should be very proficient and capable of working with fractions. It's just that in this case, it's more efficient not to do so. Sometimes, however, you may have to, so make sure you can. Okay, so all we have to do here now is take the inverse and multiply it by matrix B, and we will solve for x. So let's get that going, shall we? So we can say, therefore, x, which is given by matrix xy, is equal to minus a half of 5 minus 3 minus 4, 2 multiplied by, what was that again? 5, 7. Okay. 5, 7. And now what we have to do is multiply these two matrices together, and then we'll bring in this minus a half afterwards. Okay, so remember how to multiply matrices together, right? You have to multiply the elements in a row by the corresponding elements in a column. So let's go. So the first element is 5, and the first element in the row is also 5. The column is also 5. And we have to add the minus 3 by 7. Now we're going to go with the bottom row and this column. So that's going to give us minus 4 by 5 plus 2 by 7. Okay, so let's go down and see what happens there now. So we have minus a half. 5 by 5 will give us 25. Minus 3 by 7 will give us minus 21. Okay. Minus 4 by 5 will give us minus 20, and 2 by 7 will give us 14. And we're almost home free. 25 plus minus 21 is essentially 25 minus 21, which gives us 4. Minus 20 plus 14 is minus 6. Now we can multiply that minus a half by both terms on the inside of the matrix. So minus a half by 4 and minus a half by minus 6. Minus a half by 4 will give us minus 2. Minus a half by minus 6 is positive 3. Therefore, the value of x is equal to minus 2, and the value of y is equal to 3. Okay, so let's just do a brief recap of what we learned in this video. We will initially be given a pair of equations to solve for two unknowns. In this case, x and y, they can be any two unknowns, any two letters. First thing to do is to create a system of matrices based on the equations. We do so by taking the coefficients of the algebraic term and creating a 2 by 2 matrix with them. We then take the algebraic terms themselves and create a 2 by 1 matrix. And on the right hand side of the equation, we simply pull the two values that were on the right side of the equations initially given and create a 2 by 1 matrix with them. The next thing to do is to label your equations, which will facilitate statement making. So I did say earlier in the video, I will show you the one statement you must write, which is this statement down here. I would always say put these statements, but I know some of you guys just want to be extra efficient. I put these statements almost every time I do my working, right? So of course it means we have to find A inverse. We know how to find the inverse of a 2 by 2 matrix. We take 1 over the determinant and multiply by the adjoint, which we can see the working for here and a version of it here. Like I said, I prefer to leave the fraction on the outside to facilitate more efficient working below. Following from there now, we simply take that inverse and multiply it by the 2 by 1 matrix on the right hand side of the equation. Simplifying and solving will give us the values for x and y. Okay guys, so that's all there is to this video, right? It's a lot shorter than my regular videos, but we were able to keep it short today because we put in the work before, all right? Preparation is key, right? So remember, just watching this one video and trying this one question is not going to make you an expert at solving simultaneous equations using matrices. You need to practice, practice, and practice some more. And while you're practicing, please don't be afraid to make mistakes. I make them all the time. Mistakes are your friend. They let you know what not to do. And if you have a growth mindset, the belief that you can achieve whatever you want to achieve if you put in the work, when you are making mistakes and struggling, your brain is still growing. There's scientific research to back that up, okay? Anyhow guys, if you found this video helpful, please give it a thumbs up. If you are finding my channel for the first time and you're liking the content, please feel free to subscribe. And of course, share these videos with anybody else who you think might benefit from them. All right, guys. So if what you are doing in your studies is not working, then you need to adapt because change is the only constant. All right. I'll see you next time.